Are you looking for ways to ace your JAMB Physics exam? Look no further. In this video, Mr. Matthew, an experienced JAMB Physics tutor, will be sharing with you his proven strategies on how to ace the JAMB Physics exam in 2023. Mr. Matthew will be providing you with valuable tips and advice to ensure that you pass your JAMB Physics exam with flying colors.
Solution to JAMB 2021 Physics. Question 16. If the fraction of the atom of radioactive material left after 120 years is 1/64, what is the half-life of the material? Simple question, so we'll look at that. Duration of decay. After 120 years, the remaining material is 1/64. So express that will be 1/2⁶. We simply tell you that the half-life, there are 6 half-lives. So with 6 half-lives, so use the number of half-life to divide the total duration. 120 years divided by 6. So the half-life of the material is 20. So the answer is B. Question 17. A certain radioactive source emits radiation that has found to be deflected by both magnetic and electric field. The radiation is what? So what are the major properties? If it is deflected, a radioactive material, so first of all, you know the radiation is not X-ray, because X-ray is not a radioactive material, so we eliminate that. Okay, and then the radiation also is not ultraviolet ray. Ultraviolet ray is not a radioactive material. So what we are left with there now, we are left with beta and gamma. So first of all, let's just do a little review about radioactive material. So you have a radioactive source, and then the radioactive source has alpha particle, and then you have the electric field on the right with different plates. So if you look at the plates that are there, so we have these plates, the positive terminal and the negative terminal. Then you have alpha particle inside the radioactive source, inside the shield. So if alpha particle is positively charged, so it will be attracted to the negative, so it deflected towards the negative plate. So that is for alpha particle. It's negatively charged, so it's deflected towards the negative plate, because the law of electrostatics is a positive charge is attracted to negative charge. Okay, so let's look at the next one. Beta particle coming from the radioactive source. So allow it to, if it is emitted from the radioactive source, so what happens is deflected, highly deflected to the positive plate. The reason is that beta particle is deflected more than alpha particle that you saw. The reason is that beta particle is lighter than alpha particle, and is deflected towards the positive plate because it is negatively charged, so positive attracted to negative. But the next one is gamma particle. It has no charge, so when it's emitted, it travels undeflected. So if you look at this one, gamma will be undeflected, to not be deflected by magnetic and electric field. But the only thing that will deflect there, so the actual answer to this question is A. Question 18. The inner diameter of a test tube can be measured accurately using a what? So if you have micrometer screw gauge, no. So if you have the test tube, so the inner diameter, the distance within the inner portion, what do you use to measure that effectively? So you cannot use a ruler, you cannot use a micrometer screw gauge. So the difference is between a pair or divider, no. and then a pair of vernier calipers. So the actual answer is the vernier caliper. Question 19. Two bodies of masses with the ratio 3:1. They experience force imparted to them, acceleration in the ratio 2:9 respectively. Find the ratio of the force the masses experience. So you have this mass 3m, then you have the other mass 1m. So the ratio of the masses is 3:1. So you already know that. And then the acceleration on them, the acceleration on the first one is 2 meters per second square, while the acceleration on the second one is 9 meters per second square. So if you want to find the force is equal to mass times acceleration. So this one is going to be 6m. Then the force on the other one will be 9m. So find the ratio of the forces. So you find the ratio. So you have ratio 6:9. 6:9. So you divide with what is the lowest factor that can divide both of them? 3. So divide both sides by 3. That will give me 2:3. So the answer is C. Question 20. A particle of mass 10⁻² kg is fixed to the tip of a fan blade which rotates with the angular velocity of 10 radian per radian. If the radius of the blade is 0.2, the centripetal force is what? So if you know that the centripetal force is equals to mv square over r, so where the linear velocity is angular velocity multiplied by r. So with that, if you put that in place of v squared, so we have that the centripetal force is equal to m square of the angular velocity multiplied by the radius of the blade. So based on the color coding, so we have m, we have the angular velocity 100, then we have the radius 2. So substitute, that will give me 20 Newton. Question 21. A vibrating string has a tension of 40 Newton and produces a note of 200 Hz when plucked in the middle of the length of the string. The length of the string is on alter and the tension is increased by 120 Newton. Then the new frequency become. So we are just trying to exploit the factors affecting the frequency of a sonometer or a jitter or a vibrating string. So when you know that, so the frequency of a vibrating string F is equal to 1 over, is directly proportional to 1 over the length, then the square root of the tension divided by mass per unit, the mass per unit length. Okay, so it's a measure of the thickness. So if you look at that, so quickly from that, we know that the frequency is directly proportional to the square root of tension. So if you do that, so if you remove the tension and remove sign of proportionality, introduce a constant, so F square is equal to KT. So if you look at the two situations, so F square over T1 is equal to F square 2 over T2. So this is the tension for the second condition, tension for the first condition. So substituting the parameter given to us, we have 200 Hz when the tension was 40. Then the second one, the tension was increased by 120. So add it to the first one, that will give me 260. So what is the new? So you solve this, just cross multiply. So you have that. That will not give me, so the square root of that will give me 400 Hz. So the answer is D. Question 22. We have a parallel arrangement of 3 ohm resistor and a 6 ohm resistor which is connected in series with a 8 ohm resistor, and the potential across the 3 of them is 30 volts. So if you have this one, this is a diagram of what you have there. Now, what is the current in the 3 ohm resistor? There are 2 ways to approach this question. You can find the current, find the combined resistance, then you calculate the current flowing in that flows to this junction, and then the current will now be divided using the law of splitting of current at a junction. So when the higher current will flow through the 3 ohm at this point, so because it has the lowest resistance. So let's look at what is the combined resistance. So we have the combined resistance is going to be, you have 1 over the reciprocal of resistor 1 and resistor 2, then you add it in, combine it in series with resistor 3, which is 3 ohm. So if you do that, combined resistance is 10 ohm. So what is the current flowing there? So if you divide that, current will give me 3 ampere, which is V over the total resistance will give me 3 ampere. So the 3 ampere will now be split by this. So that is 1. Or another one method. Well, let's finish this method before I talk about the other method. So current in the 3 ohm. So it's going to take the larger share of the ratio. So between the 3 ohm and the 6 ohm. So multiply by the current coming, they split it and divide. So that will give me 2 ampere. Another method is for you find the voltage across this one. So multiply the current. So if you use this, the current is 3 ampere. So use it to multiply this. So the voltage across the 8 ohm is 24 volts. So subtract 24 volts from 30. So you are left with 6 volts. So the 6 volts across these two of them. So the voltage across them, both of them is the same. So you have 6 volts. And if you have 6 volts, so what is the current across the 3 ampere? So that will be, what will I use to multiply 3 to give me 6? So that will give me 2 ampere. So that is the second method. Question 23. A 60 watt and a 120 watt domestic lamp are used on the 240 volt main. Which of the following statement is correct? So if you look at them, both of them are used on the main. So since we are talking about power, so let's look at the power. The power across each lamp is the voltage divided by the resistance. The square of the voltage divided by resistance will give me. So let's calculate the resistance, make arrow set of formula. So that will become V squared divided by the power. So we have the resistance across the 60 watt lamp is 960 ohm. So then the resistance of the 120 watts lamp, that will give me 480 ohm. So if you look at it, so the resistance of the 120 watts lamp is lower than the resistance of the 60 watts lamp. So if you look at that, arrow 120 watts is less than arrow 60 watts. So the answer is D. Question 24. A converging lens has a focal length of 20 cm. The lens forms a real inverted image of the same size as the object when the object distance from the lens is, well, this actually is a giveaway question. When an object is placed at the center of curvature, it produces the same size inverted image at the center of curvature. So if focal length is 20, center of curvature is 2 times this, which is 40, so it's direct. But let me show you how you can use formula to calculate that. Using formula, you know that the focal length is this. So what is the magnification? Since V over U is 1, so if the two objects are the same size, that means the distance, the object distance is equal to the what? Image distance. So I've already been, so I said based on ray diagram, both of them as the center of curvature. But so let's use the formula. 1 over U plus 1 over V is equal to 1 over F. So you know that. So if you substitute that, so if you do that without substitution, so we can now have, so 2 over U is equal to 120. So you do that, cross multiply. 2 times this, 40, is equal to U. So U is equal to 40 cm. So the answer is A. X-rays are very useful in all of this except one, in the treatment of bone, correct? In the investigation of structure of crystal, correct? In the detecting defect in metal, correct? In the determination of the estimate specimen life age, no. We don't use X-ray to determine the estimate of, you use what? Radioactive element, not X-ray. So this one is just a deception. So we're trying to confuse radioactivity with production of X-ray. So the answer is D. Question 26. If calcium has a work function of 1.9 electron volt, calculate its threshold wavelength. So let's look pictorially. The work function is equal to Planck constant multiplied by the threshold frequency. So if you have that, the frequency here is the work function, that is the function, the minimum frequency before electron can be released from the surface of calcium metal. So that is the threshold frequency. Then, so if you do that, we are given the work function, so which is 1.that electron volt. So if you substitute, we are looking for the threshold wavelength. So the threshold wavelength, so threshold frequency is the same thing as the speed of light divided by the threshold wavelength. So from here we can make H sort of formula. So lambda threshold wavelength is equal to Planck constant multiplied by speed divided by the work function. So substitute your value based on the color coding. So we have that, and that gave us 6.5 times 10 raised by minus 7. So the answer is B. Question 27. We have to do with compressing gas. When a gas is compressed at constant temperature. So let's see how that happens. So let's look at a situation where you have gas molecule colliding with the wall of a container, and take note of the pressure. That's average pressure is 12.5 at the constant temperature of 30 degree 300 Kelvin. So take note of this pressure. So let's reduce the pressure, the volume of the gas. We reduce the volume of the gas. What happens? So you see the rate of collision with the wall increases, and the pressure rose to 18, that is almost 19, 18.9 atmosphere because of the reduction of the volume. So when you compress gas, the volume, the pressure increases because the rate of collision of the molecule with the wall also increases. So let's look at in this case, we have gain kinetic energy, increase slightly, move at the speed so that the pressure is unchanged, then make more impact. So which of this one is correct? So when gas is compressed, the molecule make more impact per second on the wall of the container. So that gives us the answer as D. Question 28. The note from a plug jitter string will have a low pitch if the string is thick and short, thick and long, thick and slack, thick and short. So let's look at the analysis. The pitch of string is determined by the frequency. The pitch is affected by the frequency of the string, and therefore sonometer or jitter is string. The frequency is given by this formula. It's inversely proportional to the length. That means, and then directly proportional to the square root of tension and mass per unit length. So what does it tell you? Frequency is inversely proportional to the vibrating length. That means the shorter the length, the higher the frequency, the higher the pitch. So the longer the length, the lower the pitch. Okay. Then the second one again, frequency is the frequency is directly proportional to the square root of the tension. So the more the tension, the higher the pitch. So a tight string will produce a high pitch note. Then the frequency is inversely proportional to the square root of the thickness of the string. That means the thicker the string, then the lower the pitch. Okay, so that's why you see that thick string produce low pitch note. So if you look at the combination of this, so for you to produce a low pitch, the string has to be thick, and then the string has to be long. So long string, smaller frequency or lower frequency, which is lower pitch. So the answer is B. Question 29. The half-life of an element is 24 hours. What fraction of the atom has disintegrated in 72 hours? What fraction of the atom has disintegrated? So the atom remaining, and then look at that. So in 24 hours, the fraction remaining is what? Half. So the fraction that disintegrated is half. Then in 48 hours, the fraction remaining is 1/3. So the fraction that have decayed is 3/4. Then in 72 hours, the fraction remaining is 1/8. So the fraction that have decayed is 1 minus what is remaining. So that will give me 7/8. So the answer is A. Alright, let's just look at a graphical illustration of half-life of radioactive particle. So if you look at this, a scientist uses a counter to measure the radioactivity of a sample, the nitrogen-13 isotope. The counter and the sample have shown on the laboratory the reading. Then within the period of 80 minutes, he did his measurement and tabulated. What is the best estimate for the half-life of this nitrogen-13? So what you need to look at is half-life. You start, what is the starting, where did it start from? It starts from 330. So what will be the half-life? So how long will it take for it to disintegrate by half? So find half of that. Half of 330 is 165. So if you do that, that will give me approximately 12. So 165, you trace it to the line, then you trace it down to the time, you have your half-life. So here will give me half-life is 12 minutes. So that give me this answer. So this is just a past IGCSE question that I brought here to explain this. Question 30 had to do with Newton's law of universal gravitation. So if you look at two masses placed 2 meters apart, so you have mass 1 and mass 2, the blue mass and the green mass, they have equal mass and they are placed 2 meters apart from each other. Then the force exerted by each of them, force of attraction F, and the formula is given by the Newton law of universal gravitation. F is equal to gravitational constant multiplied by the product of the two masses divided by the square of the separation distance. So with that, if you want to look for the value of the mass, so you know F, you know G, you know the distance, so you make M, the product of M1 and M2 as the formula. So that will give me F R squared divided by G. And since both of them are equal, so the square root of this is equal to the mass of the body. So substitute, we have 400. 400 is the product of the two, so you find the square root of that. M1 is equal to M2, so square root of 400 is equal to 20 kg. So when the body is 20 kg, then this force of 6.7 times 10 raised to the power minus 9 will be the force of attraction between each of them. Question 31. The potential at a point with a distance of 0.3 meter from a small charge is -1 times 10 raised to the power 5. What is the magnitude of the charge Q? So remember that the potential is equal to the constant multiplied by Q divided by the separation distance. So if you have this, so V is equal to KQ over R. So substitute. So 1 over 4 pi epsilon naught, that is your value of K. So that is the value of K. So substitute, we are looking for Q. So Q is equal to VR over K. So we have that, substitute your value, and that will give me 3.33 times 10 raised to the power minus 7 coulomb. So the answer is A. Number 33 had to do with the wavelength theory of light cannot be used to explain photoelectricity because now photoelectricity have to do with the particle behavior of light. Okay, so if we look at this one, so the wave nature of light. So if you look at this, the total energy is equal to work function plus the accelerating, the kinetic energy of the electron that is released from the surface of a metal. Now, light wave, so which of this one that cannot be explained? So, light wave do not carry energy. Light wave do not carry energy. No, there is a threshold wavelength for electron emission. Then the wavelength of light is too short. The particle cannot be emitted by wave. So if you look at all this one, light do not carry energy. Light carry energy. That can be explained by the light component. So, but the threshold that until when you emit light on the surface of a metal, until it gets to a particular frequency, which is called the threshold frequency, the metal cannot release electron. So that is a particulate nature of photoelectricity. So it cannot be explained by the wave theory of light. So, but the other ones can be explained. So B is the answer, which cannot be explained by photoelectricity. So we go to question 33, had to do with equilibrium. Which of the following statement is not true of an object in stable equilibrium? It's not true of an object in a stable equilibrium. So if you look at this one, a body walking on a tightrope is unstable equilibrium. Now for stability, the center of gravity must be low, the base must be broad, and then if you apply force on the object and you remove the force, the object should be able to return to the original position when the tilting force is removed. So a boy walking on a tightrope is unstable because the base is narrow, the rope is tiny. Then a balloon on a smooth horizontal table, if you look at this one, it's not so stable. Then you look at a ball resting on the inverted hemisphere, it can easily fall off when you tilt it. Then a ball in the middle of hemisphere table, so this one here, so it's here. So if it come roll here, it will roll back again. It can return to its original position. So this one is stable equilibrium. So if you look at this one, object in stable equilibrium. So D is the correct answer to this. Question 34 had to do with latent heat of vaporization. Now, one thing you should know is that petrol produces a cooling effect when it's poured on the hand, because so the evaporation of the petrol, that is when the liquid is converted to gas, then that process of evaporation leads to cooling. The evaporation of petrol causes cooling effect because of its low latent heat of vaporization, which is extracted from the hand on cooling. So the reason for that is because petrol have low latent heat of vaporization. That is why if you pour it on the ground, on the hand, it can easily evaporate. Question 35 had to do with rectilinear propagation. Which of the following observation cannot be explained using the rectilinear propagation of light? So rectilinear propagation of light means light travels on a straight line. So if you look at this, all this question here, so formation of annular eclipse, straight line, production of real image because light travels is a production of image by a PO camera because light travels. So the only answer here is because diffraction of patterns of light. So that is the only one here that is not a function of light traveling in a straight line. So the answer is A. Question 36. Neutrons are used to induce artificial radioactivity because, so let's look at what happened. If you have a nuclide that you want to bombard artificially, so you have a neutron, and you know that inside the nuclide you have proton and neutrons. So because if you fire this neutron into it, the neutron has the ability to penetrate deep into the atomic nucleus because it is neutral, and so there is no repulsion, electrostatic repulsion between the proton. And so the only repulsion it has is the mass repulsion from the nuclei that are there, and then this mass. So there is no electrostatic repulsion. But if you use alpha particle and beta particle, there is that component repulsion that comes from the electronic, the charge that the alpha and the beta has. So, and this high penetration of neutron into the nucleus of an element can upset the proton-neutron ratio inside, and then make the particle to become radioactive. So the major reason is that nuclei is neutral and it is highly penetrating. So the reason for this is, so A is the answer to this question. Question 37 has to do with surface tension. Which of these methods cannot be used to reduce the surface tension of a liquid? Cannot be used to reduce the surface tension. So if you look at all of them, 3 of them will reduce the surface tension, but 1 of them will increase the surface tension. That is, reducing the temperature of the liquid will make the surface temperature tension to increase. So the answer here is D. Question 38 has to do with the current 2 ampere passes through a straight wire in a uniform magnetic flux density of 2 times 10 raised to minus 2 Tesla. What force per unit length is exerted on the wire when it is inclined at 60 degrees to the magnetic field? Well, this is a simple question. Now, in this question, so one should know that the force on a current carrying conductor is Bill sine theta. I call it Bill sine theta, where the magnetic field multiplied by the current multiplied by the length of the wire is directly proportional to the magnetic field. The stronger the field, the stronger the force. The stronger the current, the higher the current, the stronger the force. Then the longer the length of the wire or the coil, then the stronger the force. And then you will have the angle component, because it has to be perpendicular. Okay, so the orientation of the wire, the direction of the flow of the current with respect to the magnetic field is very, very important. So if you look at this one, so but we are looking at what force per unit length. So that means I will divide this force by the length. So if you do that, you have force per unit length, so it's equal to Bi sine theta. So substitute your value, that will give me 3.46 times 10 raised to minus 3 Newton per meter. So the answer is C. Question 39 or question 40, because the first question number 1 is actually the question that has to do with the type of your question. So that's why we have 49 questions. So which of the following characteristics distinguish a p-type semiconductor? So a p-type semiconductor is a conductor that has the majority of its charge carriers that are holes. So a p-type, mainly the charge carriers there are holes. So that is just this question. So these semiconductor questions are basically giveaway questions. So that brings us to the end. I wish you good luck as you prepare for your JAMB. So subscribe to CEPAM. You have opportunity to have this rich review.
You kindly like and share this video
for your JAMB.
Subscribe to Super Easy Physics and Mathematics, CEPAM, and turn on your notification bell.